Now that is for a straight line, and that's why it's straightforward. But what if you had to look for the slope of a curve? Now that's where calculus comes in, differentiation. The slope of a curve, that is the rate of change of y with respect to x when it comes to a curve. So I'm going to clean up this now. And let's have a curve. And we'll see how it behaves when we're looking for its slope. So we have something like this here. And let's say you have this, something like this. This is a curve, all right? Now keep something in mind. A curve does not behave like a straight line. If you picked any 2 points on a straight line, you'll get the same answer for the slope, all right? But if you decided to pick any point on this curve, the slope of this curve at that point would be different from the slope of the curve at another point. So what I'm basically saying is, even if I had this point here, and I had another point here, okay, and I had another one here, each of these points will have a different slope. But the question is, how do I find the slope of a curve? So like I said, that's where calculus comes in. So let's say we wanted to find the slope at this point, all right? So we'd make it easier for ourselves by making another point and drawing a secant, that is a line that crosses any 2 points on a circle, all right? By drawing that line and finding out the slope using that line. So we have something like this. And we are looking for the slope at this point, all right? We're looking for the slope at this point, but we make another point here where the line cuts through, okay? And so we have our triangle. We make a straight line. Now let us identify the x values and the y values, all right? So let's read it off. So we have this. This is our x1, and this is our x2. Correspondingly, this is our y1, and this is our y2, all right? So you see, this follows the same principle as if we're looking for a straight line.